Good afternoon, ladies and gentlemen, and welcome to this webinar. Hopefully you can all hear and see me, see my screen, my home screen of the Titanic signature building. And what I'm going to do is I'm just going to take you through initially a little preview on the MasterSeries and what it's all about, and then we'll go through into the wind analysis. MasterSeries, just a refresher, because we've got a lot of people here coming in today from all over the world, and users and non-users. So the MasterSeries is really three different configurations: the Building Design Suite, the Power Pad, the Masterport Plus for portals, and Build Your Own. So if you only want connections, that's all you take. You only want masonry, that's all you can take. What we're going to be focusing on today is really how it interacts with the Building Design Suite and Power Pad. So if we look at the Building Design Suite just as a general, you'll see it's a fully modular system. So we have frame analysis, nice big frames, wind analysis, and BIM integration. Then you can add on to that basic core your finer elements, your dynamic, looking at your response, and even your seismic and looking at your earthquake stresses and forces. And then from a design point of view, you can add in your steel, concrete, your composite floors, and your connection design, and even your timber design. So all of those are all part of the Building Design Suite. Now I'm just going to go through these two. I don't need to go through those. And then into Power Pad. Power Pad also has frames, portals, beams, and wind analysis. A bit simpler wind analysis, but it still has that full capability in the wind, plus your steel, and some of those other standalone modules that are available. And then obviously then into the portals, which again can have wind analysis, and it will be a similar application on the wind analysis. So I'm just going to close down that, and let's start and do a simple frame. So let's start in MasterSeries 2019. The 20 isn't coming for another month or two, so excitement there, but I'm not going to show you anything about that. It's all still top secret. And I'm going to log into both MasterSeries and Power Pad as a license on my network license. You can see we are operating on a 2019-15 version. So it is actually only a few weeks old, an update. And I'm going to go in and do a very simple quick frame, little box frame, and put some wind loading on it, just to show you the process. So simple wind, create. Now I can either do a floor plan or a multi-story, and in fact in my case, because I want to be very quick, the multi-story is going to be even quicker, because I can come into the multi-story with my supports, and I can say, well, let's just go for 3 spans by 3 levels and accept all that, and I can then just go, let's go and copy everything into the 3rd dimension, and we're going to create connecting members, and I'm going to shift into the Z-axis by say 5 meters and apply. Number of shifts will be useful, and I'm going to say 3 shifts and preview. I'm happy with that and apply. So a little square box frame. I could delete those bottom members, but that's not going to be of any significance to me. Now the first thing I'm going to do is I'm going to put in some bracing. So let's put in some bracing members. Not add members, but add bracing. So we're going to add some vertical bracing, and we're going to put in some bracing that is in fact going to be flats, and they're going to be, I think, 150 by 12, and I'll actually put them in as normal steel 275. So I went the wrong way there, by 12. And I'll make them bracing, tension only, and I could even put them into a group, but I'll not bother. So what I'm going to do is I'm going to say that the bracing goes from there up to there, and I'm going to do it from there down to there. And I'm just actually going to do the exact same thing on these front and back faces. So we now have bracing in all four faces, and that would stabilize things. But if all my columns are pinned, that's still going to cause problems, because in different directions you're going to get instability. The second thing we need to do is we need to come along and we need to stabilize the floors. Either stabilize the floors by putting bracing into them, or by using the deck. So I'm going to turn around and say, yes, let's go for an auto select. I'm going to put a 200 thick slab, Young's modulus 27, and I'm just going to, in apply mode, apply that very straightforward to there and call that 1. Add another one, we'll call that one 2, put that there, 227, and then apply a third one. We'll either call it 3 or R for roof, and apply that there, and we will now have it as a 227. So what have we got? If we look at this in 3D, we'll see that we've got 3 plates, 1, 2, 3, at each level, and they act as a diaphragm action so that the internals don't need to have bracing in each direction, and everything works fine. Now in my case, very simply, I probably don't have pinned members at the minute other than the bracing, so let's have a wee quick look at my restraints and end releases. Yes, it's only the bracing members. So what I'm going to do is I'm going to take one of these and I'm going to release it, put it in the actually take that out. I'm now going to copy that, and this will be the master member, and I'll copy the release, put it in the front view, and I'm now going to copy it to all of those and all of those and all of those, and apply. So I now have all these pins all throughout, and that would cause me problems otherwise with stability. Now the last thing I'll need to do is my static supports. They are fully fixed. I don't need fully fixed. What I would prefer to see is pin just with a torsional restraint to give me stability. And that's all I need to do from a modeling point of view. I want to add in some levels, because levels are useful when you start to do wind loading, and the usefulness of them is that it uses that for each level for calculating the changing wind pressures as you go up buildings. So levels are the key to getting different pressures at different heights, particularly in very tall buildings, slender. So the last thing I need to do now is to look at applying the wind loading. So let's look at the wind loading panels. Need to first of all set directions, and we'll tell it that I'm going to use the wind analysis. That would be useful. And I'm going to set 4 directions. I'm going to have internal suction and internal pressure. I am working to the Euro code, so that's fine. We will use the designer's guide methods and UK factors, and we will set the angle to north, put it in plan, and we'll say that north is now at 22 degrees. So there's north over there in relationship to our XYZ plane of our frame. And now 2 things need to happen for the magic. So let's go and look at what's next. Done that. We don't really need to do that because we're not in the BS. We need to tell it where it is. Where's my frame? So I'm going to come and I'm going to choose somewhere down here, and I can just click and then zoom across, or I can go in and say, ah yes, I'm right out here, London. But in reality, anywhere we can put a national grid reference. Now you can also use a website called Grid Reference Finder to type in your postcode, and it'll give you your accurate grid reference to paste in here. And that is a lovely shortcut. We do also have, so that you can move things quite accurately, quickly, say let's go to Carlisle. So there's Carlisle, and we'll say, well actually we're actually just over there from Carlisle, and that will be giving you your wind pressures. The other thing that we're looking at in here is that we're going to walk across and see the site data obstructions are standard for that location, and there's nothing in the way of it. As you can imagine, in there it's quite a distance over to the first town of any significance. Sea, land, country, again you have your fetches, and it is doing a wee bit of graduation for the different directions. And then you have your distance to crests, so there are some crests and everything of significance in that direction. So again, of interest to you. And then finally the report generation. In fact, we should use the Eurocode method because we're using Eurocode, which simplifies it in some respects. And we're going to use 24 as a wind speed, that's correct. We're going to have it for a full year, all year round. It's not a temporary structure. And we will go for 72 segments when calculating. Now, for either very special buildings such as power stations, for prestigious buildings we can go for 1 in 120 year, or for BFNL, for nuclear power stations we'd probably go to 1 in 10,000, and that does increase values ever so slightly. Standard is 50. We can also, if we're dealing with agricultural or other reasons, we can reduce that to a, say, 25 year or 1 in 10 years. In my case, I would prefer to stay with the 1 in 50. So we've got our 1 in 50, and we can see our heights come through from our levels. So it's going to give us all the information here at the different heights. So at the different heights is giving us all the information, and we can see that we are getting at the uppermost height in one direction 0.9 of a kilonewton per meter square, because these are in newtons rather than kilonewtons. So all very nice and neat. We've got these 12 values that we can then apply to the structure because we've told it the directions we want to consider. Very straightforward. All we need to do now is to paint that onto the structure. So wind panels. First thing I'm going to do is I'm going to do this manually. So what I'm going to do is I'm going to choose a panel, and now I'm going to choose another panel, and you'll notice immediately it ignores the bracing in the paneling, and that's because they were put in as bracing members, so that they are selected separately. If I go here, you'll see that all those were applied as bracing members because we said they were bracing members. We can also add more members into that bracing group if we really wanted to and have fun, but in my case I'm just going to go back to wind panels. So I can come along and create my panels. I can turn around and say, well, actually I want it to be vertically spanning, or I want it to be two-way spanning because it's masonry, so to the columns, to the beams. But what I cannot do is add in any of these members because they're not in the plane, so it looks after planes for you, and I just come along and do the same again. As you can see, because we've got no ground beams in this case, it's just assuming that that's caught by some other mechanism in there, as you would do normally. But what I can do is I can come along and delete all those, so delete those two lists, and I can say auto generate, and it's now done it horizontally spanning throughout for all of them. Now for this roof I would probably span in the longer direction. So in search mode, click there, and then I would just turn around and say no, 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 span that direction for the roof. And there you go. And that's how simple it is to do the wind loading on a simple square box. Still needs to be done. And now we look at the actual values we're going to get. So that was the pretty picture. We now look at the wind directions. We have created these wind directions, and you can see where we're having our suction is in green and positive pressure is in yellow. So we're getting high, medium and low. And if I turn on the values, we'll see the coefficients of 1.3, 0.8 and 0.2, as you would expect. If I turn on not the coefficients but the actual values, we will see 1.35 roughly down to 0.21 roughly in that edge. And that's just for that wind direction W1. W2 will be the 90 degrees to that. So it's coming on positive, and we can see the 1.85 in the center here, 3.5 in the edges, and then as we walk down through it, we get lesser and lesser, as we would expect, straight out of the codes of practice. And then we have the opposite, and finally the opposite. All very straightforward and nice. So what we can now do is we're going to also look at the p-values. That means what's the values when I have internal pressure. So these were suctions plus internal pressure increases these values, as you would expect. If I went to S1, that's the W1 with internal suction, so that should reduce those values on the roof and here, but it will increase these values. So that's all great and useful. And for those who want to, we can turn around and look at the zonings that we have on our structure to help us understand how the structure has been applied. What I'm going to do now is I'm going to go to something a lot more complicated, and we'll walk through that. So what have we got? We've got a awkward shaped building. Put it into 3D and it looks a wee bit more easily understood. We have pitched roofs, we have multiple pitches across here, we have overhangs, we have little parapets, we have canopies, positive and negative direction canopies. We also, if you put it into plan, you will see that we do have a little bit of inset stories, so low, medium, higher, which is very interesting in its handling of the structure, and it's something we want to talk about and learn. So we have a lot of bracing in this structure, so let's look at how the bracing is handled. We can see all the bracing members here in blue. We can see the roof bracing and the wall bracing. But obviously the bracing is not in every single level, so of course, yes, we already have applied this semi-rigid stiff deck to each of the floors. Just take off the 3D to make it less chunky. And level 2, level 3 and level 4 attic, and then the roof is braced, so we're okay. So we've gone for stiff deck in each of those, which means that the intermediate bays will also all send their forces back to the bracing members. Loading cases, we only have the one case at the moment, and we're going to work on that. So first of all, let's close this down. Let's walk through the wind loading in more detail. So directions. Yes, we'll use wind analysis. Yes, we'll go with and use double click to get 2 values, double click to get 4 values, and in fact double click again we get 8 values, but that's a wee bit of overkill. The method will be directional, but it will flip over to being Eurocode in a minute. Angle to north I've set already at 12.5 degrees. You just flip that on the plan, you'll see that the angle north is just up here over to the left slightly. Ground level, if we were going to submerge the first meter of our columns, we could put in a value here of 1 meter. Also very, very useful. Also very useful when you're doing a building on top of another building, so that you can actually allow for the wind to be at a higher altitude and pressure. Now, that's that done. Next, wind reduction globally loaded value members. That's not necessary to the Eurocode. Everything looks after itself. Site data. This time we're going to go and we're going to flick over from having a locked site. I'm going to turn off the lock, and I'm going to go for an Irish grid reference this time. So scrolling up, and I am going to go for, and I'm going to pick Dublin down here, and then I'm going to pick just to the south of Dublin, just there, and within 10 or 15 meters. For this example it won't matter, it's just right on the coast. Gets you a very interesting dominant wind pressure coming back down off the Wicklow Mountains. And if I'm happy with that, I'll just lock that down. Again, Grid Reference Finder will find your Irish grid references from your Irish postcodes, or you can just pick your address and go. It's very straightforward. So again, we're at an average basic of 24 because we're that so much further south, and lock that in. So that's my site I'm going to go for. Site obstructions we're happy with. See, topography, report. We're in the Eurocode standard, and we're a once in 120 year. I'm happy with that. It's quite an important building, apparently. And everything else is fine. So that's all we need to do. We just need to come out of this again and just drop down through, and now let's look at how clever we can do the wind panels. Remember, we have this auto generate, so I have no panels here. We're all going to do them horizontally spanning initially and one way, so I'm just going to now say auto generate, and off it goes and creates all the panels. Now I do have one or two little problems, and one of them is in fact that I don't have this here because it's just, I need to correct that bit. It thinks that the column here is the whole height and therefore moves this little upstand to there, where it should actually be two separate panels and that this be its own upstand. And I will correct that in a moment. You'll see the canopies are handled separately. You'll also see that the overhang canopy is handled as a separate surface, and it's found all the interaction of the surfaces automatically, and it's automatically worked out the most intelligent direction each time for you. If you have one that's spanning the wrong way, then we can work on that and change it as you saw previously. Now, the problem with this, doing it this way, is that we think this is A and this is B and this is C, because we're dealing everything from this front face, whereas it doesn't take this as a leading edge and then this as a leading edge to do that. So, and that could be problematic if I went to my wind directions and asked for the A, so you can see how things are happening now. Which direction am I working in? I'm not certain which direction I'm blowing my wind in. I'll see in a minute coming through. And you'll see that it's A's there and this is B's. So, you know, if I go for the opposite, here we go, that's A, and that's seeing as a B when clearly it's a leading edge and a B. So the way to get around that is very, very simple. We just delete them all, we put it in the front view, and we start to slice and dice our floors. So what I'm going to do is I'm going to use this filter to look at only this level. I can take the canopy and I can say auto. Sorry, that was deleted. I meant to say auto. So there we go. We've got these levels in here and these two parapets. And I don't need to see those values. I just need to see that basic value. And W, yeah, so I can see all the different surfaces. Now what I want to do is to come back out to full front view, and now I'm going to do the next level up. That's already there, and we just say auto, and it's now done that stripe. Back out to full front, filter up to there, auto, and it's done that. And then back out front, we have about two more to go, filter up to there, auto, and then back out front. And we don't really need to do that one separate from this one because that is wall and then that's roof, so we're okay if we look at it all to catch them in one go. So we can catch them all in one go, there's not a problem there. So what we're going to do now is in front, and then just say auto. So now when we come back out to the full frame, you'll see all of these different inset stories and things like that. Now, I said I needed to do a wee bit of a correction, and in fact, it's actually corrected itself. We're all okay. Now, the other interesting thing is that it has identified everything for us. And if we actually take off this structure and look at it and rotate it around, I'm looking for a particular little problem I introduced into the frame. Here we go. If we look at this area here and turn on the 3D, we have a beam coming in to another beam, and clearly from a glazing point of view there will be something there, although structurally it won't be that important. So we need some way of transmitting the load onto this and then up to the top and bottom, and we do that by putting in what they call dummy members, and that is how we get those surfaces that need an extra member to subdivide them into done. Very straightforward. So that is an amazing piece of work. So if I now come along just in full view, just zoom in, turn on the wind analysis, we've got our pretty pictures. So let's go and look at W1, and we'll see that for W1 we have these, and you'll see it's detected that this is another leading edge, and off it goes. And leading edge and another edge that's recessed and everything. So if we go and flip it around to the other direction, which was the third one, this is where it gets interesting. That's your leading, that's your leading, and then that and that are leading, whereas previously you were going to go from A's to B's, and this could have been a B as well, but where it isn't. In fact, it would have been still been an A, and then this would definitely have been a B when it's not really a B, it's a A. And if we look at our values, you'll see that it's going A's and then C for A, B, B. So it's all looking after it so much more intelligently and more accurately. And again, This surface is an AB, and so is this an AB, and so is this, and so is this, because they are all frontal surfaces at the front of it, whereas it wouldn't have done it as accurately if you did it in one go. It would have been 90-95% accurate, but in complex frames it's better to do it in slices. Where you have a little small inset area, it's not worth the effort to do it. But here we have all of this done. Now, what's the next thing to do? Well, the next thing to do is to look at loading cases. And if I look at my wind loading cases, I don't have any loading cases. I could come along, and remember we used W1 to W4 to designate the 4 different directions of wind. So what we would need to do is to come along to loading combinations, and the combinations do a dead plus live plus a W1, or a dead plus live plus a W2, or a W3, or a W4. And that's going to take a long time to write out one at a time. We have 2 ways of getting around that. And because I'm in a lower resolution so you can see it, I just need to scroll down. And one way will be to import loading cases from one frame to another. So I could go and say import the wind loading from another frame. And that's very clever. But the other way is to use to auto-generate. Or even update. So auto-generate. And I've got a dead plus live. So I'm going to go for D1. D0 and L1, ultimate and service, and we'll just keep it simple, 610, not the A and B, and we'll have equivalent horizontal forces as per the wind loading directions. So it's going to create about 5 or 6 loading cases there because of the wind, the notional loads being included. We'll have a live load only for deflections. We won't have a dead load only, so the live load only was service only. Dead plus live plus wind we're going to have with dead and live, and we'll use all 4 wind directions automatically. And again we will use the 610. And we'll include the pressure and the suction cases. And then we'll have dead plus wind, and again we'll include the suction cases. What we could do is we could also duplicate this, and in what, well, that doesn't need duplicated, this does need duplicated, so what I can do is say copy, add, oh sorry, we don't need that one, that was we did copy, so this is the second copy of the dead. So this is the first one, and the first one we're going to say that the wind is the leading, and in the second instance we're going to say that the live is the leading. Now for the dead plus wind we're also going to say that the dead load is the favourable loads. So we're covering all of our bases, and all we need to do now, and I'll just check, yeah, one, and replace, and we now have 4 directions. Internal suction, internal pressure gives us 12 times all the different permutations of dead, live, winds and whatever, and sway stabilities, notional loads if you want to call it that. We now have 102 loading cases. Naturally some of them are quite irrelevant, but we have serviceability and ultimate. So we would then analyze this up, and that's it, done. So can I analyze this? Not certain if this is stable enough to analyze. It's a pretty straightforward frame, there's no FE in it, so it should analyze in under a minute. There we go, it's going to say it's just under a minute of pure analysis. And done. So there we go. If we look at our results, graphical, let's look at deflections with geometry. And we can see there's virtually no movement there in the dead plus live. We would expect that. The notional loads are again giving us nothing. If we go for the wind, we can see we have this movement and we have this movement because the bracing is not, there's just too little bracing for the amount of movement, and I have a problem. Something is going what I would call walkabout, and therefore in my case I would need to think about putting some more bracing in. Back to 1-to-1, and we see this here is a wee bit unstable, this nodal location here, so there's something that's not happy here under the wind. I suspect that that's 3 members that are pinned and it's just lifting up. But I always like to look at things and see in each of the directions, do I have much movement? So other than that, I've got another one in here. Actually, I think that's the same problem, just viewed from another angle. So yeah, so I just need to think about the restraints there. And if I go to my nodal end releases, yeah, I've got 2 pins there, so that's moving up and down where it shouldn't be. Likewise here and here, so there's a wee bit of instability there, not giving us the rigidity we would expect. But this is all about the analysis of the wind and not the design of the structure. So we can just go in quickly into that level. And in fact, we do have views, so I could say frame view, give me level 1. Level 1 is the drop down, level 2 will be the floor. Yep. Here we go, and if we then see our pins, and where are we getting it? Problematic. Around here, I think, yes, it was around there, where we don't have columns underneath. So we can see the columns there and there, so we can now ascertain, yes, these are the ones that weren't done properly, these 3. So restraints and releases, just take them out both sides, and that would give us a lot less deflection around that area. So that's how simple it is to do wind loading. Now, 2 or 3 things. It's not all automated if you have something awkward. And one of the best areas I find is if you go into the wind panels, and you choose a wind panel, you can come along and you can put in a funneling coefficient and beta value if you so desire. Quite frequently it's not really important, that significant, the funneling, as you might think. If you look at the codes, the ratios are actually quite limiting during which time funneling has an effect. So it's not as big a problem as you think it might be. You also have the ability to go in and override the wind pressure if for whatever reason you want in this direction to have 2 kilonewtons on this all the time in that direction. You could override that, so that's not a problem. So if you now take that and look at it as the CP, but that's not in the right direction, that's probably looking at it in direction 1, so that will override. Yeah, and it's all very straightforward in there. So you can override the values to allow for funneling. You can also, where it's not seeing it as a parapet, tell it this is a parapet. Wind on both sides is parapets. So you can say, no, this has wind on both sides. If you look over here, you'll see again wind on both sides. And for parapets, you can also set this thing called the solidity value. So if it's a hoarding of some sort, you can actually say, well, it is, but it's slightly permeable, so you can actually put in a solidity value. So if this was not constant but was wire mesh type upstand for the parapet, then you could go in and put in a solidity value of 0.75 or something like that to reduce the amount of pressure that takes. So you have those lovely facilities, and you also have the nice facility. If we didn't know where this building was, or this building was not in the UK or Ireland, then we would need to turn around and modify the loading. So what we need to do is go to our wind panels and into our site data, and what we would then do is, first of all, we would need to have to turn off the UK directional factors and make it 1 all round. Or you could put in user-defined ones if you knew that from your country what the ratio of dominant winds are. Secondly, you would turn around and say I want to use a user-defined Q value, and that's it. So it's going to work on those heights and take the values for those heights. So we don't do anything else in here. What we now do is we trundle back to our loading, and it is in here under the wind directions that we now have the ability for each of the heights that we designated. We can now turn around and put in the value of Q. The default is 1000, that's 1 kilonewton per meter square. So I can turn around and say, well, at 5 meters up, I'm going to have 1.1. At 10 meters up, I'm going to have 1.2. So these are the standard heights in the codes for you to go all the way up. You can also, if we're doing with BS design, put in the diagonal reduction factors in each direction, but you don't really need to. But again, that is when you're being very, 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 very accurate, and most times you're not going to be to the nth degree. It is pretty safe to turn around and say, well, I know the highest pressure I have at 12 meters up or 15 meters up is 1.2 kilonewtons per meter square is the Q value. Just pop that in and use it for hour. And that is the other way of doing it. What is coming from the wind analysis then is the coefficients are still correct. These are the directional coefficients are still out of our design codes. So not the pressure but the direction. So if we look at one direction, these values of 1.3s and 0.8s and all are all still codified for the shape of the building. So the shape of the building we're looking after, because we are designing to Eurocode, it is just the basic wind pressure, the Q values that we're taking from another country's location. Now, the other thing that I believe my colleague introduced for me was an example, if I can find it. When you have a building that's tall and short in the direction of the perpendicular to the wind, that is that direction there, or in the direction of the wind, not the face that the wind is applying it to, but it's not that width that we're interested in, it's this width here. You end up with the case of stepping your heights. So what we have here, if we turn on our wind pressures is a case of we're getting 3, 6, 4, 6, 4, 3, and then 8. We're actually getting it stepping up the building because of the physical height that we are working with. But the interesting thing is that only applies in that direction, and it really only applies to the front face, not to the side faces. So if this stepping of a uniform and then a varying and then another then a uniform portion, so it is going to do the height building up for buildings. So that's another little thing that people ask sometimes, but the thing is, it doesn't always apply. It's only tall and slender that it applies to. How do you deal with roof panels where you can have positive and negative pressure? Most of those will be generated automatically. It's really only on the portalized surface that you can have that. And there's two ways of handling that. You would actually introduce a W5 and a W6 to get the alternate value of wind no directions, and then you would just come in and apply a value to tell it to do that. Now what you're looking at doing is overriding the default surface. Take this surface here and you come along here, you could turn around and say, well actually it's a W2 because it's going to be blowing in perpendicular, and you want that to be the positive value, and then you'd create a duplicate W5 that would be the negative value in that surface, and that's how you do it. I will probably do a short video on that in its entirety just to give you a bit more clarity on that. However, and it's a very good question and point, if we were to go into portals and the Masterport Plus, we would be getting that all done automatically. So let's just go into a portal. It's some sort of 3D portal. Here we go. Canopies, parapets, the whole shebang, different spans. And what you're talking about is, in particularly in portals of shallow slopes, you can get a positive and a negative value because the wind just can't make its mind up. Well, the nice thing is that in this Masterport Plus, it will actually do both of the values. Have I turned on wind analysis? So into the editor, spans, columns, lean-tos, cranes, mezzanines, 3-day floors, gables, and bracing. Yeah, I need to apply wind loading. The frame will look after itself in a minute. I'm just going to come back out of that in a second, and it should regenerate. Oh, there we go. So now we've got, out of the editor, we've got our wind directions, and you'll see it is W1, and you'll see W2 is also, but it is with the pressure rather than suction on this leading edge. So in the wind analysis, in the portals, it will look after, and then that's your gable. And because we're an asymmetrical frame, it'll do it in the opposite direction, and you should have a 5 as well. And again, that is the pressure rather than suction. So in Masterport Plus, it does all of that automatically. So ladies and gentlemen, I would like to thank you all for attending today. If you don't have the wind analysis and want to try it, just give us a shout and we will get you up and running with a trial on the software. If you don't have any of the MasterSeries and want to try it, again, just come and request a free trial on the software. And I'm just going to go into the home screen, and all you need to do is just go start your free trial, pop your details in and submit, and you will then get a download to download the software. If you're an existing user, you will also be able to go into our client area and view all the videos on the software. So this video itself will be uploaded here. So here you are, it will be in here. So there's the previous webinars. So you'll get that in there. You'll get access to all of them in there. And in fact, from the home screen, people ask me, and I don't know why it's not as apparent as it should be. The resources are where you find things. That is where you go to get straight access to the videos. That is where you go to get access straight away to the manuals. Back again, that is where you go to get access straight away to the tutorials that are stored on your computer, and these are relevant to the current version you are working with. So we were working with MasterSeries 2019, so it is the 19 tutorials and getting started. So if you look at the tutorial, it's all nice and detailed, a simple frame, and off you go. If I go to the TO3, which is the big version, you'll see it's the same frame, but in this case we take the same frame, make it into 3D, and then we stuff some wind loading onto it. And we've got internal loading, area loading, and here we go. We're starting to do wind loading, and in our case we are building in the car park very near to our offices, because this is quite a simple postcode to get access to. And it tells you in there exactly how to grab a grid reference from Grid Reference Finder, in this case Irish Grid Reference Finder, and then apply it into the program. So the tutorials are all very, very powerful and useful. So people, thank you very, very much, and have a great day. Thank you.